Hello children, this is for standard 12. I'll be doing special integrals. So you will just see by giving you different examples, it'll be very clear when to apply special integrals. Okay? So I will start with the tan inverse formulas, and before I do special integrals, I would like you to introduce or explain how you do completing squares. You know that x square plus 2bx plus b square, yes, is x plus b whole square. A square plus 2ab plus b square is a plus b whole square. If it's minus, this will be minus, right? Now suppose you are given x square plus 4x plus 5 and you have to complete a square. Not that this is a perfect square. The entire thing is not a perfect square. This must be a perfect, this is not a perfect square, you know, because this has to be 4, right? So it's a perfect square plus a number. Some quadratic will be a perfect square minus a number, and some quadratics will be perfect squares, right? So if it's not a perfect square, remember, just take the first two terms which contain x, the variable. Just keep the constant there, okay? Don't touch the constant. And second condition is the coefficient of x square should be 1, because we are bringing it in this format, right? So therefore, this is 2bx. So what is half of 4? So we take 4x, half of 4 is 2, add it square, that means we are adding b square. 2b is coefficient of x. So we are taking half of the coefficient of x, which is 2, okay? And then even it's a minus 4 or plus 4, you just take the half, because minus 2 square also will become 4. And then because you took this additional, subtract, not subtract 2, subtract 2 square, and then just copy this number. So this becomes a perfect square, x plus, right? X plus 2 whole square, and 5 minus 4 is 1. So the quadratic expression is not a perfect square, it will be a perfect square plus a number, or a perfect square minus a number. Okay? Why I am doing this, you'll just come to know when I am going to do now special integrals. Okay? Next one is, suppose you have, now this is 1x square, right? Suppose you have the coefficient of x square. It's of the form, this format, ax square, okay, of the format ax square plus something x plus a number, right? So what do we do there? Some number, it will not be square, the form of square. So for example, you have 2x square plus 5x plus 8, right? It's not a perfect square, you know that. And therefore, we just take the x part of the quadratic, and I told you what, coefficient of x square should be 1, right? So we take common and we make it, because 5 is not a multiple of 2, we write 5 by 2. You took out 2, divide by 2. X, and here it's a multiple of 2, so 2 4s are 8. If it's 9, you'll write 9 by 2. If it's minus 11, you'll write minus 11 by 2. Divide by 2, multiply by 2. That's what you're doing, right? And this one you take. So now you have taken this. Next term, to make it a perfect square, then next part is, what is half of 5 by 2? 5 by 4. Half of 5 by 2 is 5 by 4. That is my b. So 5 by 2x plus 5 by 4 whole square minus 5 by 4 whole square. Because you added the square, b square, you added it, and therefore you subtract it, and the 4 as it is, but it should be inside the bracket, because all this doesn't matter because you're just adding and subtracting. So you have this. But remember, so what happens here? This becomes a perfect square. If it's minus 5 by 2x, it is in the form of a minus b whole square, plus 5 by 2x plus. So you have 2, and this is your b, and this is your a, x. X plus 5 by 4 whole square, because twice 5 by 4 will give you 5 by 2, right? So then, and then you are left with minus 25 by 16 and plus 4. Remember, there's an 8 outside. Okay? So that doesn't matter. You're only arranging what is inside the bracket. So let the 2 be as it is outside the bracket. Do not disturb it, right? So then this becomes x plus 5 by 4 whole square. And then you have 4 minus 25 by 16. That is 64 minus 25. That gives you 9 and 5, 39. So positive, 39 by 16. If it's minus 4, then you get a negative number, right? So 16 fours are 64 minus 25, that becomes 39 by 16, right? And this doesn't matter whether it's minus or plus. I told you if it's not a perfect square, ax square plus bx plus c is quadratic. If it's not a perfect square, it will be a perfect square or not a perfect square. Not a perfect square, it will be a perfect square plus a number or minus a number. That's all, right? Now this is with the 2 out. Why I am taking the 2 out and completing square? Because this is square of root 2x. So your b will not be half the coefficient of x. It will be half the coefficient of x only when it is 1x square. Because then your 2bx, your x is not x. Your first term is not x, it will be root 2x. So I do not want that, right? And why I do not want, there are two advantages for that. You'll be seeing when I'm doing special integrals. So this is how we complete a square. Now, why have I done this? Now we are doing special integrals where you have tan inverse. So you all know that dx by x square plus a square, right? You all know that dx by x square plus 1 or 1 plus x square is same, children. So this is tan inverse x plus c. And if it is dx by x square plus a square, children, right? X square plus a square or a square plus x square is same. So do not think that x square should be written first. So this is 1 by a tan inverse x by a. A stands for, you don't have, in the question it will not be given to you that it will be a square. It will be a number. So the square root of the number is your a. If it's 5, your a is root 5. If it's 9 by 7, your a is 3 by root 7. Okay. So here, and the other one is the third type, which will be in the form of x square plus 2bx plus c, right? So 3 types of denominator. Be very careful. Again, I'm telling you, the numerator should only be a number. It should not be a function of x. Because if it's a function of x, children, there are many ways of doing. The approach becomes different. So if you want to use this formula, tan inverse x or 1 by tan inverse x by a, and this will complete a square. For example, after completing a square, you get x plus minus whatever b square, and the constant becomes a square, some number, because that a square is the result of c minus b square. Okay, c and the b square. So that is, so it's plus, and you get plus, don't need to be tan inverse. If it's minus a square, it's a different formula. And it will not be given in the form of a square. It will be just be a number. So a is the square root of the number, right? So in this format, the answer is 1 by a tan inverse, the linear part, that is x plus minus b by a. The linear part. And the linear part, why I take the coefficient of x square as 1? Because I'll always get in the form of x plus or minus a constant square. The constant I'm calling as b, and differentiation of this will always be 1. Is it clear? So seeing this format, and once you understand this format, this will continue for the other formula, same manner. Only you have to put a different formula. That's all. If it's minus a square, that will become 1 by a, 2a ln of x minus a by x plus a. So depending on which formula I am going to apply. So let us see few examples on this. Okay. So I will have, children, the next video, few more examples. It will become very easy. Okay. Few more examples in the sense with x, with power greater than x, the denominator, degree of numerator greater than degree of denominator, with an x and a number, or substitution, then it becomes, so there are various types. So once I teach you in one type, it will become very easy for the others also. For example, if you have now examples, right? We are working out some examples based on tan inverse x by a. Okay. So here you have dx, and I give you like 2x square plus 7, right? 2x square plus 7. No x, no function of x, no function of x in the denominator, children. Okay, so here you have, and constant is allowed. If this 5 you can bring it -2, you can bring the -2 out. So now there's a coefficient of x square, so please take it out. Intelligent people will do it. Some people are very fast in mathematics will do it very easily. I can also do mentally, but then the safest way for anybody. Okay, so 2 common, so the denominator becomes x square plus 7 by 2, because 7 is not a multiple of 2, so 2 into 7 by 2 is 7. So here you got, now this is a. A is what? Now my a is root 7 by root 2, which you can write root 7 by 2 also, square root of the number. So every number is square of something, right? So I am never unhappy that I'm fat or obese or whatever because somebody is fatter than me. So life you can enjoy that way by thinking that the other person does not have as much as me. So we can be happy. We'll always be happy. Okay. So here 1 by 2, right? Now what is my a? Root 7 by root 2. 1 by a. So root 2 by root 7. Reciprocal. You can write a root of 2 by 7 also. Tan inverse x. Square root of this by square root of this. Root 7 by root 2 plus c. So finally it becomes, this gets cut. So it becomes 1 by root 14 tan inverse root 2 x. X is not under the root sign. And plus c. Got it? So here you got this. Now let us see one with quadratic. Right? Now if it is dx by, not only every time it will be this, suppose you have like dt by, you have t square plus say 25. This is mental. Now what is its dt? So therefore this will not be tan inverse x. This will be tan inverse t by 5. That's all. This is mental. Right? So, but the variable is t, so don't write x. Now coming to the quadratic. That's very important. You must be knowing these simple ones. So you have dx and you have x square plus 4x and say plus 9. Okay. Not a perfect square, but it's quadratic. And step 1, there is no function of x in the numerator, right? It's just 1, or it can be a number. And then you have a quadratic, which is not a perfect square. So we'll make it perfect square. And coefficient is 1. So keeping all that in mind, what is half of 4? 2. 2b is 4, so b is 2. So this becomes x plus 4x, x square plus 4x, half of 2. 4 is 2, so 2 square minus 2 square plus 9. Why minus 2 square? Because you added one term extra, 2 square. Okay, so this becomes a perfect square. So dx by x plus 2 whole square, and 9 minus 4, that becomes your 5. Now you saw always I take plus, right? Because my mind always accepts positive things. I like positivity in life, right? I hate to be negative, right? So therefore, suppose this is minus, this will be minus, then this will be minus. That's all. Right? Middle term is minus, it will be a minus b whole square format. Now you got it. What is my a? A is root 5, because 5 is root 5 square. So this becomes 1 by a tan inverse, the linear part, whether it's plus 2 or minus 2, whatever it is, by a. Finished. The sum is over. Don't forget to write the constant, right? Because this is indefinite integrals, right? So this is completing. Now what is the third type of quadratic? Where there's a coefficient of x square. Okay, there's a coefficient. So seeing this, now let's take another example where you do, it is not 1x square. There, with x square, you have a variable, right? So suppose you have dx and you have a 3x square and you have a minus 5x and you have a plus 15, something like that. Okay. So here I will not complete a square. First remove that 3. Okay. So here I used to tell my children, this is the rhoda. Okay. So it will cause a thoda and you will get marks thoda and milega mar with hathoda. So why I am saying that? Because You will not be, because this is not a perfect square, this is root 3x square. So root 3x whole square. So therefore I take out the 3. Okay, nothing here, only a number 1. So I got, after taking out 3x square minus 5 by 3x plus 5. Because 5 is not a multiple of 3, so divide by 3, multiply by 3. This is multiple. If it's 11, you write 11 by 3. That's all. So that much you know how to take out common, right? So now what is half of 5 by 3? You don't have to worry about the sign. It will become 5 by 6, right? That is my b. 2b is 5 by 3. Don't worry about the sign. Just take the constant. So this is what I will add now. Square of what? 5 by 6. I'll copy these two. Add square of 5 by 6. Subtract square of 5 by 6 because I've added. And the number 5 untouched but copy. Don't forget it. Just because you don't need this, don't think that I'll erase it. Your marks will be erased, right? So, therefore, you have this as a perfect square. It is in the form of x square minus 2bx plus b square, which is x minus b whole square. And my b here is minus 5 by 6. Okay? So, therefore, it's 1 by 3 dx. Can you see the board? Yes. So, that is x minus 5 by 6 whole square because the middle term is minus. And what are the numbers left? 5 minus, not 5 by 6, 25 by 36. So what is 5 minus 25 by 36? This is 180 minus 25 by 36, which is 155. Yes, 5, and you have 7 minus 2. Yes, 5. That is 180 minus 30 is 150, and that is 155. So this is 155 by the positive. If it's negative, it can become a plus a number or a minus a number if it's not a perfect square. Plus a number will become tan inverse, minus a number another formula, right? So format is same format. So I'll explain this in detail clearly so that you can understand the other special integrals very fast, right? Completing square is the fast method of doing it. Now you got this, now you know what it is. My a is root of 155 by 6. My a is root of 155 by 6. Am I right? So here you have 1 by 3 is the common one. Don't forget that, right? And then you have 1 by a, reciprocal of this, 6 by root 155, 6 by 1 root 155, and that is tan inverse x minus 5 by 6, the linear part, and by a, root 155 by 6, this whole thing plus a c. Am I right? So plus a c. Now you see in this, now you can take the 6 out and then simplify. So finally the answer will become, as I rub it, this will become 2 by 155, LCM 6 by 6 will get cut with this. So that is the final answer. Okay. So here you saw the quadratic. Now what happens if it is? Now I'll continue in, I don't want to make the videos too long. Okay. So I should make it such a way that you want to see my next video. Right. Now what you have done is completing squares. So if there is a constant in the numerator and in the denominator you have a quadratic expression of the format x square plus a square or x plus minus number b whole square plus a square. That will be tan inverse. So you will see that what happens now. See the different examples which I'll do it in the next video of mine. Suppose see the sums which I give you. If I give you x square by x square plus 4, copy it down. Copy it down, right? You just copy it down so that you will know what I'm going to do next. Or you have like 3x cubed by 2x square plus 9 dx. Or you have 3x plus say 5 divided by x square plus 6 dx. Am I right? And the last type is quadratic. You have x square plus 1 divided by x square plus 6x plus 12. Right? Or you have simply, so what will be the same power? Or you have 3x minus 1 divided by 2x square plus 5x plus 19. Whatever. You can see the difference. So that means please mark. And what I taught you just now is the numerator should have only a constant. Now the numerator has functions in x. First one, the degree of x is less. The numerator has ax plus b form. That means x and a number, only x. Only number is you can do directly, right? The other one, the degree of numerator is greater than the degree of denominator, the power. So, and then why do they give formulas only for ax plus b and a quadratic? Okay, and they just give a number with a quadratic. Why they don't give others? Because if the degree of numerator is greater than or same as the degree of denominator, we do long division. We do division, so we get a quotient which will be only a function of x, and the remainder will be, because quadratic, the remainder can only be x and a number, or only x, or only a number, right? That is why the formula is only for 1 by ax square plus bx plus c, or it is cx plus small d divided by a quadratic. They don't give x cube and x squares because they have to divide. You have to divide that. Here the power is less, right? So here this time we are going to continue in the next video, because one video I don't want to do at a stretch because it should be interesting. Children, if it's interesting, please like, share and message me. So we'll continue this. What happens if in the numerator, instead of only a constant, we have functions of x? Am I right? Thank you. Bye bye. Hope you liked my video.